Are you supposed to have this on?
Oh my goodness. I hold my breath in the absence of a mask. I mean, in truth, probably holding your breath is better than having a mask, right? But it would be troubling if we all had to hold our breath all the time, right? That would be tricky. Let's see here. So we introduced the concept of a function, right? We talked about the domain and the range. We talked about a little bit about what the graph of a function means. So I want to talk more about that because I think you guys will benefit from further discussion of that. So suppose you're given so that's it's too tiny. Make it bigger. Suppose you're given that this point is like minus 3, 2, right? And then you got a function like that, all right? And here's y, here's x. This point is, let's say, 8, 3. And I'll also tell you that here's a little reference line. Let's make this reference line like that. This point at the top is, let's say, minus 1, 8. All right? So here we're given y equals f of x. I mean, is that reasonable? Could this be the graph of a function? Why or why not? We can look at the vertical line test, right? If you put a vertical line through any point in the picture, we just get the intersect with the graph just once, right? So it passes the vertical line test. What's the domain of this function? What are the possible inputs given this graph? We start where? We start at minus 3 for x values, right? And we go all the way over to 8. But I don't know if you can see it or not. Let me make it super big. This is like a circle here, and there's a solid dot over there. So that solid dot means that minus 3 is included in the graph. And this 8 over here, on the other hand, is excluded because of that. That's what we mean by that. It doesn't quite get there. It gets almost to there, but not quite there. So like the function's defined at 7.9997, but it's not defined at 8. 8 is outside the domain. What's the range? That's irrelevant to us at the moment, but what's the... I was just buying you some time to think. Can you tell me what the... Now, I'm telling you that this right here is not below that point, okay? So given that, it's unambiguous. The range goes from... Well, right idea, but the range refers to the y values, the outputs. So 2 included over 2 over to 8, right? And 8's also included, right? Yeah, negative 1, 8. Yeah. So you guys tell me. F of minus 3 equals fill in the blank. F of minus 1 equals fill in the blank. F of 8 equals fill in the blank. I'll do the hard one. The last one's a hard one because f of 8 is not defined. So in this case, we say undefined or does not exist. In other words, my question, what is the value of f at 8, doesn't even make sense because f is not defined at 8. See? How about f of minus 3? You guys can make me do all the work. Okay, fine. 2? You know, if you went to the gym and you had like a personal trainer, and then you made them do the sit-ups, it wouldn't really help, right? Just, I mean, kind of the same thing. F of minus 1? Not that I would really know about personal trainers, but anyway. I heard an 8? Yeah. So, very good. Let's look at another example. So, well, fine, I'll stop it here. Let's see here. Pi, you guys know pi is a real number, right? So pi is just a symbol for like 3.14159 stuff. Yeah? This thing I'm graphing is actually what's called, well, the picture is mostly signed, but I'm going to do something a little bit annoying to it. I'm going to just delete this here, and I'm going to delete that there, like that. And I'm going to delete that point right there, and I'm going to delete this point right here just to be annoying. So this is actually at pi over 2. This is at 3 pi over 2. This is at minus pi over 2. I regret making this example. Minus 3 pi over 2. But I've gone this far, I'm going to finish it. So my question is, given that this is y equals f of x, can you tell me what the domain is? And I will not expect an interval notation. We're going to use set builder here because it's a lot easier. I'll get us started. The domain of f is x such that what? Minus 2 pi less than or equal to x less than or equal to 2 pi, and x is not equal to what? Not equal to minus 3/2 pi. It's not equal to minus pi over 2. It's not equal to pi over 2. And it's not equal to 3 pi over 2. I mean, if you want. ask yourself the question, does Dr. Cook want to grade this question? No. You're just going to go skip it. Well, now you're trying, that's easy for me to grade. So if you're going to promise me if you promise me you're going to skip it, then I gotta think about it. I mean, because if people skip problems, then that makes it grading super easy.
I'm gonna do the problem, but I'm gonna take the hardest route.
You're gonna do the problem, but you're gonna give me a mess of like scattershot, stream of consciousness garbage that I can't make any sense of.
Yeah, and I'm gonna spell each word out.
Spell each word out completely.
Every number is gonna be like wrote out.
You're not. So instead of writing like the number 2, you're gonna write like TWO.
Yep.
Whoa,
And put the little
that's just unfriendly.
Yeah, I'm gonna do plus, minus.
It's just. It's amazing how much just putting pi in the problem has made it like intimidating, right? Isn't that weird? Like this is just a number, but like all of a sudden this seems like way more complicated than it would otherwise be, just because that pi is there, isn't it? Anyway, that's the domain, the range. I will try to redeem myself with the example I should have done in just a second. The range is -1 to 1 included. Although you couldn't tell that until I put this here on the graph. So the set of y outputs, it goes from -1 to 1, but it never actually hits -1 or 1, so those are excluded from the range. Let me try this example again, but simpler. Sorry. I have a penchant for writing complicated examples. It's just kind of built into me. Whoop. All right, so this point is -4, 3. This point up here, let's say, is 1, 10. And this guy down here, we'll say that that's at 8, 0. All right, so here's your y-axis. Here's your handy-dandy x-axis, like so. All right. So, and I keep drawing graphs in the same color as my axes, and that's just kind of like, that's just poor form. We should use a different color, you know? So, whee! There we go. Now I feel better. And let me throw in some more points while I'm at it. This is like 7, 2. And over here you got like -1, oh, I don't know, 7 maybe. So let me start it with some easy questions. Can you tell me f of -1 equals to what? 7. F of 7 equals to what? 2. F of 1 equals to what? Ah, it was a trick. That's an open circle. Aha. See, I got you. See? I mean, it just gives us math people joy. People had the right idea, and we just, needle them over some technicality. It seems like it's what we always do, isn't it? Us unfriendly math people. But no, I mean, the reason it doesn't exist is that little circle means that it's not in the domain, right? So we say D&E. How about f of 8? And how about f of -4? f of 4, you're like, I'm going to get it this time, undefined, right? And so you said 0? Very good. So like that is the first order of business, you guys. You need to come to a clear and certain understanding of what it means for a point to be on the graph, how that relates to the value of the function and the input to the function, right? X is the input, f of x is the output. F of x is the y value, x is the, well, x value. So. Okay, now that I've got that done, how about range and domain for this example? What's the domain? Is that, I heard -4, is that included or excluded? Not included, right, so. I'm gonna help you out here. We go from -4 over to 1, but 1, that's not included, so we're gonna have to do that. And then I'll start you again at 1, and where do we go to? 8. Is 8 included, or? It is included, right? It's unfortunate that included and excluded sound so much alike. It's all about the cluded, right? But it's that in and x which makes all the difference. Stupid English. Let's see here. But so there you go. That's the domain.
So when it passes the y-axis, you have to start on the domain?
Say again?
When it passes the y-axis, you have to start anew?
No, the reason I had to start anew here was because of that circle right there. It's because that 1 was missing. If I could fill that in, then I could just go from -4 to 8. -4 not included, 8 included. How about the range? Ten is not included. All right, so you're starting me at the top, trying to make me write my answer like a Japanese cartoon. I'll allow it right to left. So 10 not included. 3, well, 3. Yep, 3 is, well, see, 3 is not included here, but it is included over there. Although you can see that my graph is kind of not quite on the level, is it? So we go all the way down to what? 0. Is 0 included or excluded? Included, right, so 0. So that would be that. Open is excluded. The square bracket is included. Yeah. Open is excluded. The square bracket is included. So.
Why on domain did we not have to write the -17 and 17?
Oh well, those are points on the graph. They don't. I mean, it just means that the value of the function at 7 is 2, and the value of the function at -1 is 7. So it gave us that particular. The reason I put those points in is so I could ask these two questions, but it doesn't really come into play deciding these. Good question. So this is one. So your homework will have questions like this in it, right? And hopefully you can. I hope I showed you enough that you could get started and finish thinking through these for yourself, right? Let's spend a little bit more time looking at the other kind of question, which is when we're given a formula, right? I forgot. There's one other example I wanted to show you. Sometimes we have something called a vertical asymptote, and so we could have, for example, y equals to 1 over x. If you graph this thing, it looks kind of interesting. It's negative over here, right? It's positive over here. Actually, this function's interesting in that it has both horizontal and vertical asymptotes. So like this is a so-called horizontal asymptote. And this guy, on the other hand, is a vertical asymptote. So the word asymptote just basically means it's getting closer and closer and closer, but it didn't actually get there, right? So what would the domain, now if I say that this is equal to f of x, let's say that this is the value of the function, right? What's the domain of f? X such that what? What's the one thing x can't be? What's the one thing that formula doesn't make sense for? Can't be 1? Can't be 0. How about that, right? X not equal to 0. Now, if we want to write that in interval notation, we would write minus infinity to 0 unioned with 0 to infinity. Because if you think about the number line, there's the left and there's the right part of the number line. They meet it in the middle. We just have to exclude 0. So that's the domain. How about the range? What are the possible y values here? Mm-hmm. So basically, you're telling me y such that y is what? Not equal to 0. So actually, this is a kind of funny function, isn't it? The domain and the range are the same set. The domain and the range, they're both just all real numbers, which are not 0. Another example, you might run into something like f of x is equal to 3 plus 1 over x squared. This one, when you graph it, it looks like a volcano that has like 3 as its base. And so I always think of this function as the volcano function. This is the volcano function shifted up 3 for what that's worth, but so this is y equals f of x. What's the domain of this one? I mean, it's the same domain as the last problem, right? It's x can be whatever it wants, except for 0. 0 is not allowed, because when you think about that formula, we can't have division by 0 again, right? So it's just, minus infinity to 0, unioned with 0 to infinity. And what about the range? What are the possible y values? Y such that what? Yeah, y is, well, how about 3? Can 3 be there? Y has to be what? It has to be above 3, right? So, yeah, y greater than 3. And I think you were telling me that means 3 not included to infinity as an interval answer, right? So if I look at your homework, say section 2.3, number 1, it's kind of got a different, well, actually, this is just a, oh man, this is just multiple choice. Why did I give you, this one's too easy. Why did I even give you guys this one? Man. Maybe you guys can answer it for me, though, if I can turn off enough lights so we can see it. Oh, thanks. You got it. Let me make it bigger. If I can find my mouse. Oh, made it too big. There we go. So here's a function, 2 over 5x plus 3. It says, what is the first step in finding the domain of a function? Well, this function, I should say. Ooh, I don't like the wording here at all. It shouldn't say a function, because other functions don't have these things. Like if my function was f of x is equal to the square root of 5x plus 3, none of these are right. This is poor wording. This function, not a function. So here, we need to make sure that's not 0, right? So the answer would be what? Set the numerator equal to 0, set the denominator equal to 0, and solve for x. Which one of these? Set the product of the numerator and denominator, set the numerator, it should be b, right? We should set the denominator equal to 0 and solve for x. That will tell us which point we need to avoid. So this question doesn't even ask you that, I don't think, but, oh, wait a minute. Maybe I'm wrong. 7 parts? Oh, those are the other 7 problems. What x would we actually have to avoid here would be what? Minus 3/5, right? If we plug in minus 3/5 into here, we're in trouble. So the domain of this function would be like x such that x is not equal to minus 3/5. How about this one? Find the domain of f of x equals to 10 minus x. So my question to you is, as you think about 10 minus x, is there anything that can get us into trouble there? What's the domain? Is there division by 0 possible? Can we take the square root of a negative number? No, so, well, if I say anything more, I'll solve the problem. Okay? Now, I hope you could answer this question now after our discussion, right? F of 1 equals to what? I mean, you can look at this graph. You can, yeah, once you get it on your computer, I can't see it either. Once you get it in a reasonable resolution and contrast and so forth, you can look at 1 and you can see where 1 outputs to, somewhere down there, right? So I think I've showed you guys enough to do the homework here from section 2.3, right? I believe. We should be good on this one. So let me get out of here for a second. Let me just close this down. You can turn the lights back on. Thanks. I'll put this away as it's distracting me at the moment. Oh. And let's move on to the next topic here, which is linear functions, graph and slope, right? Come on. So, well, haha. So I hope I've showed you guys enough about the sections 2.1, 2.2, 2.3. If I have inadvertently left something out, and you're lost on it as you try to do your homework, just come in here and ask about it, and we'll spend some time on it in a future lecture, okay? So now I need to tell you some things about linear functions. Slopes and graphs. So here's a definition. If f of x equals to mx plus b for some numbers m and b, then f is a linear function. Right? M equals the slope, and b is also equal to the y-intercept. So slope also. The slope we can also understand as being equal to the rise over the run, which you could also write as like the change in y over the change in x. And when I say change in y over change in x, what I mean by that is you could take like y2 minus y1 and divide by x2 minus x1. That would give you the slope. Let me make a big old picture to try to explain better what I mean by that. So if this is my xy axis, all right, and my line looks something like this, all right, then first of all, what is the value right there? What happens when we plug in, what is f of 0? See, this y-axis is when x equals to 0, right? Do you agree? So this is x equals to 0, right? So this guy right here should be what? 0, comma, f of 0. Right? 0, comma, f of 0. What is f of 0? Plug in 0 into this formula right here. What happens? We have m times 0 plus what? Plus b. So when you evaluate that function, when you plug in 0 into it, evaluate's just a fancy word for plugging in the number. So evaluating at 0 gives me back b. So this is, exactly b. That point is 0, comma b. B is the y-intercept. Right? Now, this where's x2 and where's x1, where's y2 and y1? Well, this is the neat thing. If you want to calculate the slope to a line, the thing that makes a line is it doesn't matter which pair of points you pick. Any pair of points that you pick, they're going to have the same slope. So x2, whether x1, y1, and x2, y2, they could be any 2 points, as long as they're distinct on the line, and we'll be able to calculate the slope from them. So like, just in this sort of generic hypothetical picture I'm drawing here, this could be like x1, y1. This over here could be x2, y2, right? And you can picture a triangle here. And in that triangle, we've got the delta x, which is x2 minus x1. And we've got the delta y, which is y2 minus y1. So this is the run, quote unquote. This is the rise, right? And that's the slope. I mean, we take the amount we go up in y divided by the amount we go over in x, and that defines the slope. The fact that that ratio is the same for any pair of points makes this a line, among other things. So let me show you an example. Suppose that we're given that the point 0, comma 2 and also the point 10, comma 8, these are 2 points on a line. Given 0, 2 and 10, 8 are on a line, find the linear function whose graph is this line. In other words, find m and b such that y equals mx plus b gives you back a line with these 2 points. I mean, I can draw the line, right? There it is. So somebody want to get me started?
Is that a 10?
Yeah, it's a 10. Sorry, my. You're going to figure out the slope? Okay. So you said y2 minus y1 over x2 minus x1. So you want to think about this one as like the x1 or the x2 and the y2. You want to think about this one as like x1, y1. Mm-hmm. So 6 over 10, we could, 3/5, right? That's the slope. What's the y-intercept? Yeah, the y-intercept is 2. So, the line is y equals 3/2 x plus 2, right? That equal to f of x. I mean, this defines the linear function which has that line as a graph. So another definition, y equals to mx plus b is the slope intercept form of the equation of a line. Because this equation is written in terms of the slope and the intercept. Of course, you could use those to quickly graph a line, right? Graph y equals to 1 plus 2x. How do we do that? I would start with the y-intercept is 1, right? And so if you think about that, where can we go from there? You could use this. What's that? Yeah. So yeah, this means what? The slope means up 2 if we go over 1, right? Up 2 over 1. So go over 1, up 2. So like this point, which would be what? Like 1, 3. Or we could go 1 to the left, then we go down 2, right? So that'd be like over here. Minus 1, I guess. And as you can see, my, well, if I was better at putting points on, it wouldn't be crooked, but, I'm doing my best. What's another way you could do? You could just plug in a value, right? Once you get 2 points, you can draw the line by just connecting the dots and keep going, right? That's another way you could graph a line if you have the formula. All right, so any questions? Yep.
How was the slope in the middle column 3/2? I thought it was 3/5.
That is a very good question. And the answer is, well, there's no good answer to that, but so, yeah, I'll have to find an answer for that. I don't know the answer just yet. To work on it. But yeah, that should be 5. So this is slope-intercept, right? There is at least 2 other useful definitions. If line has point x1, y1, and slope m, then y equals to y1 plus m times x minus x1 is point slope form of line. That's another, I use this all the time. To me, that is actually more useful than slope-intercept. There's also a 2-point form for the line. If the line has x1, y1, and x2, y2, with x1 not equal to x2, then y equals to y2 plus y2 minus y1 over x2 minus x1, parentheses, times x minus, I meant to put y1 here, sorry, y1, x minus x1 is 2-point formula for line. Yep.
At the top, is it in red, is it done one way?
Oh, yeah, I'm sorry, that got too small. So these can all be useful. Let me actually use my point slope form for a line and show you how that works. Yeah. Usually I will ask you to leave your answer in slope-intercept form, just so it's easier for me to grade if everybody puts it into slope-intercept form. That's typically what instructors want. They want you to like multiply it out like this, you know. So example though, find line with slope m equals to 7 through point minus 3, 13. So this is very easy if we know the point slope form of the line. All we have to do is identify x1 equals to minus 3, y1 equals to 13, and of course m is 7, right? And I just put those You know, so I'm trying to buy a house right now. And like the amount you have to like sign over to get a loan these days is absolutely ridiculous. Like you basically have to sign papers that say they can share your information with everybody. It's very aggravating to me. Like you apply for a loan, you'll start getting calls from everybody and their brother wanting to sell you a loan as well. It's just offensive to me that when you do business with a business, they share your information so that their competitors can harass you. I don't know exactly how it happens. I just know I'm annoyed. But anyway, sorry about that. It's part of an ongoing trouble I have with the... Actually, I don't know what that was. Nobody talked even, so for all I know, they're trying to sell me a timeshare in Myrtle Beach or something. Okay, so what do we got? We can use the point slope. So I'm just going back to this. I would recommend that you memorize this. And that would be good advice, except that I also said you could have a formula sheet for the next test. So I would advise you to put this on your formula sheet and understand how to use it. I think that's true of every one of these, yeah? Okay, so y equals to 13 plus 7 times x minus a minus 3. So y equals to 13 plus 7 times x plus 3. There you go. That's the point slope form of the line. What if I wanted to put it into slope intercept? What would I do? We just do what? Y equals to 7x, right? Multiply, we get what? 7x plus 21? 21 plus 13 is what? I think it's 34. So 7x plus 34, that would be the slope-intercept form of this line. See, let me do one more example for you here. So the first example I did was kind of easy because I gave you a point on the y-axis so you could figure out the y-intercept, right? But if I give you two kind of like arbitrary points and we want to find the equation, it could be a little bit troublesome. So this is 1 comma 7. And put the other point down here somewhere. Let's say minus 4 comma minus 2. I want to find the equation of the line through those 2 points. So the easiest way to solve this problem would be to do what? To use the 2-point formula for the line, right? So we could do that. Think about this as x2, y2. Think about this point as being x1, y1. So what's the slope of the line? Seven minus a minus 2, right? Divided by 1 minus a minus 4. So what's the slope? Looks like 9 over 5. And then we could go back to like point slope if we wanted. So y equals to 7 plus 9 over 5 times x minus 1. I use point slope because I know that the point 17 is on there, and I know that the slope is 9/5 because I already calculated it. And so there you go. That's the equation of the line that has those 2 points. And it's actually the same thing you would get if you just plugged in x2 and y1. I mean, if you plug the points into this formula down here, you get exactly the same expression that I just wrote there. It's good? So that's up here. It is. I used x2. So that's the funny thing, is if we wrote instead y equals to, let's say, -2 plus 9/5 x plus 4. So this would be using point slope, but with the other point. The funny thing is, it doesn't matter which point you use. It gives you the same formula. Like if we work this out, let's multiply both of these out and put them back into the slope-intercept form. So we got what? We got 9/5 x. And what is 7 minus 9/5? Seven minus 9/5 is 35 minus 9 over 5. 35 minus 9 is 26. 26 over 5. So plus 26 over 5. How about this one down here? We have 9/5 x, right? And what's 9 times 6? 36. 36 over 5 minus 2. 36 minus 10/5, which is 26/5. So that's the really kind of funny thing here, is when you go to do point slope and you have 2 points, you could use either one. You'll get the same answer. The answers will look different before you put them back into the slope-intercept form. And so that's part of the reason that instructors insist on students giving the answer in slope-intercept form, is because there are like a kabillion different these kind of formulas you can write for a line that look different on first glance, but they're really the same. Well, guys, that's it for today. So I thought I was joking, but I actually am not. We're end early today, so have a excellent rest of the week. Hey, we don't meet Friday, do we? I think next time we meet will be next Wednesday, actually. So, nope, yeah, Mondays. Yeah, it's Labor Day is day off. So, did you hit stop record or? It's okay. Thanks. Yeah, red button.